So the first subroutine uses the CSV module to read the three files, category names, supermarket layout and product key, and converts them into a list for supermarket layout and a dictionary for product key, and then returns all three. This next subroutine converts the supermarket layout, which is currently just in words, into hexadecimal values using the product key. So the key shows which word goes with which hexadecimal value, and the layout, which is currently in words, is then converted into all these values. This next one does the exact same thing, but for the user's shopping list. So the shopping list is stored under category names, so depending on what the user has in their list, that's what will show up here, and that's then converted. And then this next one calculates the distance between two sets of Cartesian coordinates. So inside it there's a distance between coordinates subroutine, which takes in two distances and works out the difference between those. And then the whole thing will do it for two sets of distances, which is what two coordinates would be. And it does this using Pythagoras' theorem in here, and then just working out the distances by subtracting the x values and the y values. The main bulk of the program is in this create locations subroutine, which takes in the hexadecimal layout and the hexadecimal list. And the first part goes through the whole layout trying to find the hex code FF0000, which is a door, and then it will set the variable door location to its location within the layout. And then it will append this to line locations, which is the locations the turtle will go to at the end of the program, drawing the line, so door location is the first item in this list. So locations is then set to be a dictionary with door location as the first value and its key being FF0000. And then for every item, the item that's in hex layout is appended to this dictionary in the same format, with the hexadecimal being the key and the location as coordinates being the value. So locations at the end of this is an unordered list of all the items. After this part, the current location is the one that you're currently at, and afterwards the next one is checked, so every location that you have to go to after that is checked, and at the end, line locations will get the one that's closest from your list appended to it. So if you need to go to bread, confectionery and vegetables is closer and you're at bread, then vegetables will be appended. The next part determines the locations of the tills, which is the exact same process as was done for the door at the start. The tills is always at the end, but there are often multiple tills in a shop, so it determines the closest one and then appends that to line locations. So this whole subroutine will return line locations, which is all of the locations for all the items on the user's list, with the door being the first one and tills being the last one. And these few subroutines are just for the turtle, so this is how the lines are actually drawn. So a square, which is what the grid is made up of, is just four sides where it goes forwards a set width, turns right, goes forwards the next amount. And width is used as a constant throughout, so that's determined at the very start of the program, which allows me to change the width if there's different devices and they want different map sizes. All I have to do is change one value and the whole map will be scaled up or down. Draw grid uses the draw square function here to draw a set of squares, one for every item that's in the hex layout. So it will draw every single aisle and its category as a certain colour based on the layout. Draw line will go from every location in the locations list in order. So it needs to be given an ordered list of places for the turtle to go, and it will start off at the first one. So here it will go to the first one, and then for every other location it will just go to it without doing a pen up in between, so it will draw a line with no gaps. Main program just runs every single bit, so it will use import from CSV to get these three from CSV format to list format within Python. Then it will use convert layout to hex to convert the layout that's currently just in the list format into a hexadecimal layout, which is a 2D array. And then it will use convert list to hex to do the same thing for the user shopping list. And then it will use create locations to turn the unordered list into an ordered list, which is the set of directions that the turtle needs to follow to draw the line over the map. Then it will set width as the constant 30, and then draw the grid using that width, and then draw the line over the top of that grid. The final subroutine, create output image, will just take the current status of the turtle canvas and convert it into an SVG drawing, which is just an image format. And then I'll use the OS module to save this image to the server where it can be accessed and shown to the client. This is the .save part. So at the very end, it needs to remove the previous output image using the OS module, and then it will use this create output image subroutine to not only make the image, but also save it